All right, welcome to our lecture on Chapter 6, continuing cognitive growth, but now we're discussing cognitive growth from the information processing approach. So if you remember from Chapter 1, reading about information processing, the whole basis of this theory is essentially correlating the way that our brains work to the way that computers work. So you see in this chart here how that happens. So for information processing, the three main areas are, the first step is encoding, which is the process by which information is initially recorded in a form usable to memory. So that's here. So if you're using the computer analogy, encoding would be where you're typing information into your computer. So that's where you're initially getting the information. And then you move on to storage, where information is saved in memory for future use. So you type up your Word document and then you save it to your USB. And then you go to retrieval, which is where you're recovering memories from storage. So you're bringing it to awareness and you're using that information. So you've written your Word document, you stored it to your USB, you then go plug it into the library computer to print it out. That's retrieval. So you have encoding, storage, and retrieval. So that's the basic idea of what's happening with information processing. So this is in today's lecture, we're going to talk a lot about memory and how we can better store memories to use them for later. And we're going to talk about attention a little bit as well, because in order for this whole process to happen, the first step is attending to the stimulus. So if you're not paying attention to something, then that means you're not going to actually encode it and store it and then be able to retrieve it later. There's a lot that goes on in the world, and our senses pick up a lot more information than we actually pay attention to. So a lot of that information is just not even brought into the initial recording in the first place. So I'm going to post this video. Since my videos haven't been working very well, I'm just going to start posting them supplementally. So you can pause here and watch this first video on the information processing model and attention. I think it explains things really well that are a little complicated to understand. So I would definitely recommend that you pause here and watch that video. And then after you watch the video, you can work through this example with me. Sorry. So in your textbook, you have this chart. This is our more complex information processing chart. It's essentially the same three steps. It's just we're dragging it out a little bit more, making it a little more detailed. So I have an example up here where we have Anne, who's 4 years old. She's looking at a picture book with zoo animals. Anne sees a picture of an animal with stripes and asks her mom what it is. Her mom replies, "That animal is a tiger. Remember when we saw one at the zoo?" The next time Anne looks at the book, she remembers that the animal with the stripes is a tiger because she saw one at the zoo. Okay, the formatting is kind of the last part of the sentence. So, working through this chart, we have information, which is her actually seeing the tiger in the book. So that's the information. She has this animal, it has stripes, it's orange and black. The sensory store now is that all that's happening here is your senses are taking in the information. So this is your sensory store. And so as you can see, this information doesn't last very long. So this information goes away within 1 second. If you do not attend to it, this is where your chart ends. So if you're not paying attention, you lose that information within a second, it's gone. If you are paying attention, then that information moves on to short-term memory. So in our example, sensory store, you would just say something like, well, she's using her eyesight to see the stripes and to see the colors, and she's paying attention, so that's now moved on to short-term memory. So here, again, if you're not using any kind of central executive techniques, this information is going to be lost within 15 to 25 seconds. So for adults, we can hold like 7 pieces of information in our short-term memory. So a good example of this would be if you're trying to remember a phone number and you don't have a way to write it down, you can remember that for about 15 to 25 seconds before you lose it. So in Anne's example, she's thinking about what the animal looks like. So it has stripes, it's orange and black, and she's thinking about maybe her memory of seeing the tiger in the zoo now that after her mom told her what it was. So in her central executive, these, which we're going to go in more detail in a second, this is basically rehearsing the information in some type of way to solidify it and move it to your long-term memory. So if you don't do this step, then you're losing the information in 15 to 25 seconds. If you use some kind of central executive technique, then the information moves to long-term memory. So maybe essentially what's happened here in this example is that she used the technique of elaboration by her mom telling her, remember when we saw one at the zoo? So she's connected the animal she saw in the book to her experience at the zoo. And that's allowed this memory of what a tiger is to go into her long-term memory. So long-term memory is your more permanent types of memory. So those are there essentially forever. And then whenever she looks at the book again, she can pull that memory of seeing the tiger from her long-term memory back into short-term memory where that's in her current awareness. So when she sees the picture with the animal with the stripes, it's orange and black, she'll remember that it's a tiger. Okay, so let's talk about attention a little bit more, and then we'll talk about this chart a little more as well. So first, attention is really important because in order for a stimulus to even be processed through that whole chart we just went through, you have to attend to it. So like I said, if you're not attending to it, that information is going to go away within once, so very, very quickly. So attention, some stimuli are going to get your attention easier than others. So we have attention getting stimuli. So things like a loud noise or a quick movement. If something in your house fell over and made a loud noise right now, you would probably turn around really quickly to see what it was. So that's attention getting stimuli. Now, attention holding stimuli, this is just going to vary. So some stimuluses hold your attention better than others. So definitely when you're talking about kids, that's going to vary. So if you have a toddler, a book is likely not going to hold their attention for very long, in the same way that it would hold the attention of an older child for maybe a long period of time. So that's going to vary depending on your age and your stage of cognitive development and what kind of stimuli are going to hold your attention. Okay, and then we have control of attention. So this is the ability to tune into certain stimuli and tune out others. And this ability increases with age. So a lot of you are having to do this right now, especially if you have kids at home and you're trying to study or do a quiz or do an assignment. You have to be able to block out stimuli that are not relevant to your exam. Let's say you're taking a test. So you need to focus on that test and only that test. So that means that you have to have the ability to shut out the noises of your kids playing downstairs, or your dog that's trying to get your attention, or the cars you can hear outside. So the ability to do that is control of attention. So young kids aren't able to do that as well as adults are. And then lastly, we have planning of attention. So this is the ability to allocate attentional resources on the basis of goals that one wishes to achieve. This ability also increases with age. So the example that was in your book was this picture here. So this picture's in your book. So what they would do is they would ask children to find the differences between the houses. So older children, what they would do is they would compare the houses on a window by window basis. So they would look at this window on this house and then look at this window on this house. Okay, those are the same. Let's look at this window and then this window. So you can find a difference there. And they would go on and on and on like that. So that is the ability to plan it. Now what you see is that younger children aren't able to plan attention. So they would look maybe here and then look down here and then look here and then look here, and it would be very haphazard. So they would get more answers wrong. They weren't able to find as many differences as the older children who were able to plan their attention to achieve a goal. Okay, so that is the basics of attention, and you know how important that is for our model here. So you see now we've added attention in. So you have stimuli, you have the sensory memory, Again, if it's not paid attention to, it's forgotten. This one adds on a couple more seconds, so it can last between 0.5 to 3 seconds if you're not paying attention. So another example I like to use for this is why you should not text and drive or talk on your phone and drive, even if you're not texting. Using your Bluetooth or speakerphone is still just as dangerous. The reason for that is it's easy to know why you should text and drive because you're literally taking your eyes off the road by looking down. But then people think, well, if I put it on speaker and put it on my Bluetooth, then that's better because I can look at the road. Now, the reason why it's not better is because you are actually physically looking at the road. Your eyes, your senses are taking in that information. However, you're not paying attention to it. You're paying attention to whoever you're talking to on the phone, which means that that information is being forgotten. It's not moving into your working memory. Working memory is what you're currently thinking about in this moment. So you're not taking in the information. So even though your eyes are working, it's not that you can't see. You're seeing it in your sensory memory. It's just that it's being forgotten quickly, that you're not able to actually use that information to make decisions about where to steer your car because that attention aspect is gone. So that's why you should not be on your phone in any kind of way, actually talking to someone or texting when you're driving. Memory are used interchangeably, but essentially what I want you to know is that that's what you're currently working on. So if you're trying to take a test, you have the or studying for a test. Let's use that example. So you're studying for a test. So you're looking at your notes at your textbook. That's a stimuli. Your sensory memory, so you're seeing the words on the page. You're paying attention, so it's moved on to your working memory, which is what you're currently thinking about. You have some kind of study technique. So maybe you repeat the information over and over again, which encodes it into your long-term memory. Now you sit down to take a test. So you have to retrieve those memories back into your working memory in order to actually answer the question on the test. Okay, so one other thing I wanted to talk about was what factors contribute to our ability to process information. So some things in your environment may impact your ability to actually accurately process information. So I'll post this video on cognitive biases as well. But we all have cognitive biases. We all have stereotypes that influence the way that we encode information essentially. So the video is about the about a shooter task, which I've actually used in studies when I was in graduate school. This is a picture from that. So essentially what you do is you, if you're a participant, you're actually playing a video game where people like this will pop up. It's either black or white men, and they have so in this example, they have a gun, but they might have a cell phone or a soda can. And as a participant, you have to push one button to shoot them if they have a gun, and a different button to not shoot them if they have the cell phone or the soda can. So your brain is having to process information really, really quickly. It's having to go through that flow chart we just talked about really, really quickly. So our cognitive biases and stereotypes are influencing the way we process that information. So the stereotype about Black men is that they're aggressive and dangerous and violent, they're criminals. So it's more likely that you will shoot at the Black man, even if he doesn't have the gun, than you would at the white man who actually did have a gun. So you can watch that video and it'll show you a good example of that. Nutrition, sleep, and mood affect our ability to process information. If you haven't eaten all day, if you haven't got good enough sleep, those things can inhibit your information processing abilities. So you're not going to be at the top of your game essentially because your body is in need of something. It's in need of food, it's in need of sleep. So that it really affects the way that you process information. So if you come to class and you haven't eaten or you didn't sleep all night, then you're not going to take in the information in the same way you would if you came fully prepared and ready to go, which is then obviously going to affect the way that you encode information to your long-term memory and then affect your performance in the class. So that applies even though we're not face to face. if you are trying to complete assignments or do quizzes, whenever you haven't taken care of yourself, your performance is going to be a lot lower than it would if you do those assignments and quizzes after you've eaten and after you've got a good night's sleep and stressed out, which goes to mood as well. If you're in a bad mood, if maybe you're sad or you're angry, you're not going to process information as well as you would if you were in a more neutral mood, essentially. Okay, so now let's talk about memory. So your textbook talks about how memory develops over the course of childhood. So with infants, there's research that show that infants as young as 6 months can actually remember things. So this first picture here is about a study that was discussed in your textbook where they tied a string to an infant's leg and attach that to the mobile here. So every time the infant kicks, it moves the mobile, which brings them pleasure. They like it. So then they eventually learn that if I kick my leg, it'll move the mobile. So then several weeks after that initial experiment, they would put the infant back in the crib and the infant would immediately start moving their leg to try to move the mobile, even if they didn't attach the string. So they remembered that would bring about that action. So that's kind of cool. However, the duration of memories is a little more fuzzy. So there's a term, infantile amnesia, which is the lack of memory or experiences occurring prior to 3 years old. So we do not have memories prior to 3 years old. Even if after 3 years, like 4 or 5, it's even hard for people to remember. But definitely, people do not remember from birth to 3 years. So research has found that we likely do have memories from those times, but it's very difficult for us to recall them. So essentially, you can't access them. And even if you were, they probably would not be accurate. A language may play a role in this. So when recalling a memory, an adult or older child may only be able to use the vocabulary they had at the time of the event. So if we're talking birth to 3 years old, you might not even have had language yet. So that makes it really difficult to then recall a memory. Plus these memories, these early memories can easily become distorted by new experiences. Okay, and then we have, there's several different types of memory, but the only one your textbook talks about is autobiographical memory, which is memory of events from your own life. So these memories are not accurate until after 3 years old. Early memories tend to fade or become distorted. So for example, you may not remember your first day of kindergarten for the rest of your life, but you have an idea, like you have certain different memories from like elementary school in general. And that's probably just because all those days you went to school from kindergarten through like 5th, 6th grade were all so similar that none of those specific days are going to stick out. You just have like general memories of what kindergarten was like. Same thing like for adults, we go to the grocery store a lot. So one specific trip at the grocery store is not likely to stick out and may be incorporated into other memories of other trips at the grocery store. So another example I like to use for this is if you have siblings, you all may remember events differently, which can cause arguments. If you remember it a certain way and your brother or sister remembers it a different way, and you all feel like you're right. So the key here is that with memory distortion, it's not that somebody is lying or making something up. This is how each person remembers it. And our memories are really unreliable. So they can change based on new information, and you just kind of mash everything together. And it ends up being an inaccurate view of what actually happened. So with adults, they also show errors in autobiographical memory, where what you tend to see is that they forget information about their past that conflicts with their view of themselves in the present. So if today you are a really good student and you're successful, but in the past maybe you struggled because you maybe partied too much at the beginning of your career in college, you might forget that information and kind of leave that out of your overall memory of who you are and who you were in school. Okay, so there are some memory control strategies to help you remember things and essentially encode things into your long-term memory. So the first one I have listed up here is repetition. So this is the easy one where you just repeat something over and over again. So like if you're trying to remember a phone number, you might repeat it over and over again until you get to where you can write it down or dial it. Elaboration is just where you're making something, you're elaborating on something. So a way that you can do this is by connecting the information to your personal life or to the real world, maybe to the job that you eventually want to have. So we tend to do this a lot in my classes where you connect it to something personal to you and makes it easier to remember. So in this Charlie Brown comic, you can see that where in order to remember his locker combination, he connected the numbers of his combination to some of his favorite baseball players. So then that way he was able to actually remember the information easier. Chunking is another technique where you see this a lot with phone numbers as well. So chunking just refers to splitting up the numbers. So if instead of having one long phone number, you split it into 3 pieces, that makes it easier for your brain to remember because it's literally tricking your brain into thinking that it's remembering 3 separate pieces of information rather than one big piece of information. So you see that with your phone numbers, with your social security number, like credit card number, you see that a lot. Okay, and then scripts is just what we discussed previously on like your trip to the grocery store. You have a script of what generally happens when you go to the grocery store. And so it helps you to kind of predict things and like what's going to happen in life. So I'll post these videos. Well, I'll post this one. This was just a clip from Seinfeld about repetition, but I'll post this one that's more interactive on chunking and elaboration. Okay, so then this chart is also from your textbook, I believe, on information processing and age. So essentially, as the brain matures and we age, we are able to process information more quickly. So this is the processing speed. So you can see it takes longer about 4 or 5 years old than it does at 8 years old. So it's getting faster as we age, which seems a little it goes against stereotypes essentially that as you age, maybe your memory gets worse. That's actually not the case. It's just that you might have to use more of those memory control strategies as you're aging in order to help yourself remember things. But really, what's happening is as our brains are physically maturing, so again, connecting that physical aspect to your cognitive aspect, then that allows you to use those strategies better, which then increases the speed at which you can process information. Okay, and the last thing I want to talk about is eyewitness testimony. So your textbook mentioned it briefly with children where preschoolers have difficulty describing certain information and oversimplify recollections that may have implications for eyewitness testimony. So young children are susceptible to suggestions from adults, and sometimes what they appear to recall is not actually accurate. Repeated and leading questions by adults may lead to inaccurate memory reports by children. So this is important because eyewitness testimony is often used in court, which makes sense because if you're on a jury and you have a witness in front of you who says, well, I was there and I saw what happened, you have no reason to not believe them, right? So it makes sense that, well, if they were there and they actually saw it happen, then they're probably accurate. However, what research has found is that eyewitness testimony is very, very flawed. And a lot of people have been released from prison based on DNA that were actually convicted because of faulty eyewitness testimony. I have this comic here that says, has someone trying to identify who they saw commit a crime in the lineup. and it says it was the cat, no, it was the woman, heck, it could have been any of them. So clearly, like, it should be easy to identify who it was because all these people are very different. Um, but it's just showing that eyewitness memory is so faulty that they can't even remember who it was. So whenever you're witnessing something under stress, like a crime, your memory is not going to be accurate because you're not accurately processing the information in the first place. And then definitely if you're being asked about it afterwards, your memory has already been distorted. This is especially going to happen with children, but it can happen at any age. So for children, you should question children right after an event and outside of the courtroom if possible, and that is likely to produce more accurate memories. So I'll post this video as well where I just wanted to show you an example from an actual case where somebody was wrongfully convicted. So you can see that these people look very similar. And basically, you can watch the video and it'll go through the whole case, but it was just that the person who gave the eyewitness identification was very confident in her identification, and that led somebody to being wrongfully convicted, and then later DNA proved that he actually did it. This video is a really great example of what I'm talking about, and I would encourage you to watch that.